Good day, students. On this clip, we're going to be going over some examples on how to evaluate absolute value expressions. We'll generate some equations, and then later on, we're going to solve and graph the equations. All right. So let's start out by evaluating some absolute value expressions. Okay. So let's write down the um, instruction for the question. This is for number one. So what we're going to be doing here, we're going to evaluate each expression. Evaluate each expression if a equals -3 and b equals 4. Alright, the first expression we're going to evaluate is the absolute value of -2a. Okay? So to evaluate this expression, we're going to substitute the value of a into this expression and then use the definition of absolute value to evaluate the resulting expression. Okay, so we're going to have the absolute value of -2. Now I'm going to take out the a and I'm going to put -3, substitute -3 for a in the expression. Alright, now multiply. Remember, when you're multiplying numbers with the same sign, you always end up with a positive, right? So minus times minus is a plus. 2 times 3 is 6. Absolute value of 6 is what? This expression basically means that 6 is how many units from 0? 6 is 6 units from 0. So there goes your final answer. Alright, let's go ahead and try another expression. What if we had the expression be negative of the absolute value of 14 minus b. Okay, so like before, we're going to substitute the value of b into this expression, which is 4, and then we're going to evaluate. So we have negative absolute value of 14 minus, instead of b, I'm going to substitute b with 4. Okay. All right, let's simplify what's in the absolute value, and then we'll use the definition of absolute value to evaluate the resulting number in it. All right, so minus 14 minus 4 is simply 10. All right, so what's the absolute value of 10? The absolute value of 10 is how many units is 10 from 0 on the number line? 10 is 10 units from 0 on the number line, so you're going to have -10. Remember, the absolute value only affects the numbers that reside within the absolute value bars. Since this minus is outside, this absolute value has no effect on it. So this is your final answer, -10. All right? Okay. Now, for the second set of problems, we're going to be generating absolute value equations from graphs. All right? So, instructions are as follows. For number 2, write an equation. Write an equation for the given solution sets. For the given solution sets. Solution sets for absolute values. Absolute values. Okay? Alright, so the first one we're going to do the A part. What if we had the graph? This one we want to sketch it properly. We're going to create a number line. What if we had a graph on 2 points on a number line? Let's say we had it on 2 and 8. Okay, so let's see, this is 1, 2, 3, 4, 5, 6, 7, 8. Finish the whole thing. So go ahead and draw a number line like this. And what if the first solution was on 2, so this is 1, 2. First solution was right here. 3, 4, 5, 6, 7, 8, 9, 10. And then the second solution was an 8. So what absolute value equation will generate these two solutions? Okay, so the first thing we're going to do here is we're going to write down the general form for absolute values. All right, so this is the general form. The general form is general form general form is basically the absolute value of x minus h equals r. Okay? Remember the center is h and the radius is r. Alright? So all we need to do is find the center and the radius, plug it into this equation, and we're done. Okay? So now what is the center between 2 and 8? There are different ways we can do it. One way we can find the center is by averaging, by doing the average, okay, or the midpoint. So what we do is we're going to have 8 plus 2 and divide the sum by 2. 8 plus 2 is 10. If we divide it by 2, we're going to get 5. Alright? Another way we can do it is we count from both ends by equal increments and see where we end up at the center. So if I wanted to do it another way, I can start from 2, take one step in from the left, one step in from the right, take another step in from the left, another step in from the right, take another step in from the left, and take another step in from the right. Bam, they meet right here. The point that they meet is 5, so that tells you that the center is 5. So that's just another way of calculating, of finding out where the center is, all right? So the center between 2 and 8 is 5, okay? So that means h is 5. Now what do we need? We need the radius. If this is the center h, right here, h, the radius is simply the distance from the center to any of the endpoints. So either from here to here, or from here to here. That's the radius, okay? So all you just simply do here is you just count. How many units from 5 to 8? 1, 2, 3. So the radius r is 3. You can count to the left or to the right. So 1, 2, 3, your radius is 3. So radius is 3. Now since the general form is x minus h equals r, I'm going to substitute these two values into this equation and we're done. So we're going to have absolute value of x minus 5 equals 3. And there goes your final answer. So if you solve this equation right here, this absolute value equation, you're going to end up with this graph as your solution set. Okay? Alright, let's try another example similar to this. Option B. What if we had a graph of this nature? Same number line. Let me use a different graphing tool. But in this case, what if our points were on 1 and 7? Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so let's just say our points were on 1 and 7. So this is 1, 2, 3, 4, 5, 6, 7. Let's say we have a solution here and a solution here. So what equation will give us this graph? All right, what equation that after solving will give us this graph? Let me make my line a little bit shorter because it kind of looks asymmetric. So let me make it a little shorter. All right. So in order to find the equation that will give us this graph, all we just have to do is write on the general form again. General form. The general form for absolute value equations is basically the absolute value of x minus h equals r. The center between the 2 points is given by h, and then the radius, which is the distance from the center to any of the endpoints, is r. So all we just need to do is find out h and r, plug it in here, and we're done. So we need to find the center first, all right? So how do we find the center? To find the center, we're going to do it 2 different ways. First way is you average the 2 points, 1 and 7. So 1 plus 7 divided by 2. 1 plus 7 is 8. 8 divided by 2 is 4. Okay, so this is going to be the center for your graph, all right? Another way to do it, you can just count equal steps from the left and the right. So 1 step in from the left, 1 step in from the right, another step in from the left, another step in from the right, 1 step in from the left, 1 step in from the right. Bam, they meet right at 4. So that tells you that the center is at 4. Okay? Alright, so now that we have the center, we're going to use that to figure out what the radius is. The radius is basically the distance from the center to any of the endpoints. So it could be the distance from here to here, or the distance from here all the way to there. Okay? So how many units from the center 4 to the endpoints? You just count, and that will tell us. Okay, so this is h. So we're going to go 1, 2, 3. So your radius, r, is basically 3. You can use that area, or you can use this area right here. You see your radius is 3. So since h, the center is 4, and the radius is 3, the solution, we just plug in these values into x minus h equals r. We're going to have x minus 4 equals 3 as a solution. So this absolute value equation, when you solve on graph, you're going to get these 2 points that we started with. Okay? So there you have it. All right, welcome back, students. We've gone over how to generate absolute value equations using the graphs. Now we're going to go into the reverse process, which is actually solving absolute value equations and generating the graphs. Okay? So for question 3, this is the instructions. Solve and graph the absolute value equations and check your solutions. Okay? And check your solutions. Now it's always good to check your solutions just to make sure that you've made no mistake. Okay, you make sure that your solutions are correct. So the problem we're going to be trying in number 3 is the equation absolute value of the quantity 3x plus 2 equals 4. Okay. All right, so let's go ahead and solve this. So first thing I want to do, we're going to use the definition of absolute value to get rid of this quantity. This statement basically means that the absolute value, it means that the quantity 3x plus 2 is 4 units from 0 on the number line. So it could be to the left or to the right. So if it's to the left, it's negative. If it's to the right, it's positive. So how do we write that? I'm going to take away the absolute value bars, and I'm going to write plus or minus 3x plus 2 equals 4. So minus is to the left, plus is to the right. Okay? So this plus or minus means we're going to have to split this equation into 2 parts. Okay? We're going to have the positive side and the negative side. So I'm going to split this equation into 2. I'm going to have the positive on the left, and I'm going to have the negative. I'm going to have negative on the left and a positive on the right. So this is how I'm going to write it. I'm going to have negative 3x plus 2 equals 4. This is for the negative component. And then for the positive one, I'll have, simply, you don't have, for positive, you don't have to put anything. You just 3x plus 2 equals 4. Okay? So anytime you have plus or minus, you have a scenario where you have 2 equations in one. So you have to split it. Okay? Alright. So notice how I retain the parentheses because they're going to affect my solution. Alright? So now that I have it split, I can solve them independently. This was 2 and 1. Now this is 1 and 1. Alright? So let's go ahead and solve this. I'm going to start with the negative part. So the negative part, I'm going to distribute negative into the parentheses. So this minus into this and that. If I distribute the negative there, it's going to become negative 3x minus 2 equals 4. Minus times plus minus. Minus times plus minus. Now let's solve this. To solve this, I'll add 2 and divide by negative 3. Okay? So let's start out by adding 2 to both sides. And then you have negative 3x equals 6. And then we divide both sides by 3. I'm sorry, divide by negative 3. Alright, divide by negative 3 to get x by itself. So you're going to end up with x equals negative 2. Alright, that goes your first solution. This one, there's no sign in front of the parentheses, so we can just drop it. 3x plus 2 equals 4. To solve this, we're going to subtract 2 and divide by 3. Subtract 2 from both sides. you have 3x equals 2, and then divide by 3, and you end up with x equals 2 over 3. So your solutions are, so your solution is going to be x equals -2 or x equals 2/3. But the question asks for us to graph, so we're going to make a sketch. It doesn't have to be perfect. So the graph is as follows. You just make a number line, and then you can just call the first mark -2. The smaller one goes to the left, and then the bigger one goes to the right, and 2/3. This is just a sketch, so this is the first solution, and then there goes the second solution, and that's it. Okay? All right. Now, we're done with our solution and the graph. So next thing we're going to do is we're going to check to see if our answer is actually correct. Okay, so next thing we're going to do is a check. Okay, let me partition my workspace so we don't get confused. Break it down again. All right, so now let's do the check. All right, so check is basically what I'm going to do is I'm going to plug in these two answers into the original equation and see if I get a true statement, okay? So the original equation is absolute value of 3x plus 2 equals 4. All right? So which candidate should we test first? Let's test the smaller one. Let's test, let's check x equals -2. All right? So if I plug this in here, do I get a true statement? If I do, then that's good. If I don't, then I made a mistake somewhere here. I have to go back and check my work. So we're going to have absolute value of 3. Instead of x, I'm going to put in the result I got, which is -2, into the x position plus 2 equals 4. Now, if I solve this, do I get a true? If I simplify with the left side, do I have 4? So the question is, -3 times 2 is -6 plus 2. If I take the absolute value of that sum, do I get 4? Is -6 plus 2, is it equal to 4? -6 plus 2 is -4. Is the absolute value of -4 equals 4? Absolute value of -4 is how many units 4 is from 0 on the number line. So absolute value of -4 is just 4. We have 4 equals 4. So that checks out perfectly. Okay, now we're going to check the second one. Remember, we had two answers. We had x equals -2 and x equals 2/3. So now we're going to check x equals 2/3. If that's good, that means that our answers are correct. So we're going to plug it into the original equation. Absolute value of 3. Instead of x, I'm going to replace x with 2/3. If I add 2 to that and take the absolute value, will I get 4? All right, let's simplify that and see. So 3 times 2/3, how do we do that? We can write 3 as a fraction, multiply across top and top, bottom and bottom. So we have the absolute value of 6 over 3 plus 2. Is it equal to 4? 6 over 3 is 2 plus 2. If I take the absolute value, do I get 4? 2 plus 2 is 4. Absolute value of 4, is it 4? Some people see this as -4. That's wrong. 4 is how many units from 0? It's 4 units. So 4 equals 4. Perfect. Since both checks work, our original answer is correct. Okay, so we're confident that our answers are accurate. Okay, so after doing the check, now I can box my solution and my graph. All right, so there you have it, solution and and the graph. Okay, now let's go ahead and try one more problem. Same process, we're going to solve, graph, and check. Okay, so for question number 4, the same process, but this time we're going to be dealing with the equation 2 times the absolute value of 2x plus 1 equals 6. Okay, so let's solve this first. So before we get rid of the absolute value bars, it has to be isolated in the sense that we can't have any coefficients in front of it. All right, so we have a 2 being multiplied by the absolute value quantity. So what we're going to do is use the opposite of this operation to get rid of the 2. So what's the opposite of multiply, divide. Okay, so we divide the left side of the equation by 2 and the right side by 2. Or you can multiply by 1/2. It's the same thing as dividing by 2. So 2 goes into self once, 2 goes into self once, 2 goes here once, and 2 goes into 6 3 times. So we're going to have the absolute value of 2x plus 1 equals 3. Okay? Now, what does absolute value mean? It means distance from 0. So the quantity 2x plus 1 is 3 units from 0 to the left or right. So how do I write left or right? That's plus, that's right, or minus the quantity 2x plus 1 equals 3. So anytime you want to get rid of the absolute value bars, you just use plus or minus and then parentheses, okay? Now I'm going to split this into two parts. The negative part, negative parentheses 2x plus 1 equals 3, and the positive part, which is 2x plus 1 equals 3. Okay? Always don't forget, you have to do the split so you don't make mistakes. So this is a negative one right here, and then there goes a positive one right there. Alright? So let's put the signs there. This is a negative one, and there goes a positive one. When we solve both of them, that will give us our final answer. Alright? So now this one will distribute the minus to both quantities. So we have negative 2x minus 1 equals 3. Now to solve this for x, you just add 1, divide by negative 2, and you're done. Okay? Let's go ahead and do that. You add 1. You have negative 2x equals 4. Divide by negative 2. And then you have x equals negative 2. Alright? Alright, now moving along. On the right side, to solve this one, all you just do, we can drop the parentheses since there are no numbers in front, so 2x plus 1 equals 3. So to solve this one, you're just going to subtract 1 and divide by 2. Alright, so subtract 1. That gives us 2x equals 2. And then divide by 2. And then that gives us x equals 1. And there goes your final answer, okay? So our solutions are x equals negative 2 or x equals 1. Let's draw the graph and then do a check, okay? So the graph is just a sketch of the solution. It's just a sketch. So this is a graph. All you do is you need negative 2 and 1. So negative 2 has a point, and then 1 also has a point, and there you have your number line. Okay, so this is a graph of the solution set. Alright, now let's check to see if our answer is actually correct. So how do we check? All we just do is we plug in the two values into the original equation and see if it's true or false. Alright, so let's do a check. We're going to start with the smaller result, which is x equals negative 2. The question is, if I plug this into the original question, 2x plus 1, right, equals 3, do I get a true statement? Alright, so I'm going to plug this in there, work it out, see if it works out or not. Alright, so let's go ahead and do it. So the absolute value of 2, instead of x, I'm going to put negative 2. That plus 1, is it equal to 3? Is that a true statement? If I multiply this out, I'll have 4, actually negative 4. Negative 4 plus 1, is it equal to 3? Alright, so negative 4 plus 1, is it equal to 3? Well, let's see. Negative 4 plus 1 is negative 3 equals 3. Now, what is the absolute value of negative 3? How far is negative 3 from 0 on the number line? 3 units, right? So absolute value of negative 3 is just simply 3. Is 3 equal to 3? Absolutely, so that checks out. Alright, now let's check the second solution, which is x equals 1. I'm going to plug it into the original problem, see if we get a true statement, okay? So absolute value of 2, instead of x, I'm going to put in this solution, 1 plus 1. Is it equal to 3? Simplify this to see if we get a true statement, okay? 2 times 1 is 2, plus 1 equals 3. 2 plus 1 is 3. Absolute value of 3 is the absolute value of 3, 3. Well, 3 is 3 units from 0 on the number line, so absolute value of 3 is just 3, right? Is 3 equal 3? Absolutely, so that checks out. Now, since our two answers check, that means our original results are correct. Okay, so we can box it and call it a day. So let's box our solutions and the graph of our solution. All right, so there you have it. So thanks so much for paying attention to this presentation. Please feel free to subscribe to my videos to get more updates, and you can share this video with your friends online. More videos can be found on notgoodstuff.com. Thanks again, and have a wonderful day.